First of all, welcome to Go Green classes, and I wish best of luck to all my students. Now, some of you will like to know that why I have named these classes as Go Green classes, because I believe that green is the, not I believe it, believe only, it is a fact that green is the color of prosperity, and green color allows movement. It allows movement. So when you join green classes, so your continuous movement, continuous progress will be there. Now, not taking much of time. Now we are proceeding for physics class 9th. Now we are going to start physics of class 9th, and the first chapter which we are going to just discuss or interact with each other is motion. In first session of motion, we shall be just discussing this motion, what is a motion, what is rest, and what are physical quantities, means what are scalar quantities and what are vector quantities. We shall be studying about all these topics, right? Or not only studying, we shall be interacting with each other. Now let's start our first topic. Yes, dear students, before going for chapter motion, we shall like to know what is physics, and we must know what is physics and how does it help us in daily life. What is the importance of this physics in our life? So to be very honest, it is very difficult to define exactly what physics is. What physics is, its field is very wide. Its field is very wide. So for one, physics keeps changing as we progress and make new discoveries. So daily new discoveries are being made, and progress is taking place in the universe. So it is very difficult to define physics in few words. So in general, it is a branch of science concerned with the nature and properties of matter and energy. Matter, solid, liquid, and gas, and energy from various sources. The subject matter physics includes mechanics, heat. These are the topics, these are the fields which are studied here in physics. Sound, electricity, magnetism, and structure of atom. And universe is also there, we know. Okay, so my sound is reaching to you, or I am reaching to you because of physics only. So this is the importance of physics. Studying physics strengthens quantitative reasoning and problem solving skills that are valuable in area beyond physics. And it also helps us here to express our creativity, to see the world in a new ways, and then to change it. The new changes are being made daily. Nowadays, sitting at home, some of you must be making new discoveries, new things to help you in daily life, to help your parents, right? So because of physics, you can show your creativity, how creative you are. Now, before starting chapter motion in class 9, we shall like to know what is mechanics. It is the oldest branch of physical science, which deals in the study of state of rest or motion of a body. Mechanics is the word from mechanic, or we can say that mechanic is the word from mechanics. Mechanic, mechanics, they deal with the machines. Machines can be in the state of rest or in the state of motion. So when you talk about the car, when your car breaks down, then you take it to the mechanic. As if your cycle is not working properly, then you take it to the mechanic. So what was the first machine? What was the first machine? The first machine, which was first machine about which we came to know was lever. An idea of this lever, first machine, was given by the Archimedes. Archimedes around 3rd century BC, right? And then pulley and screw. These all are simple machines. Simple machines, right? Here, this you can see it is a straight rod. It is used to lift the load. It's a load. It's a large. If you have to pull it, then you have to apply large force on it. But if you use this lever, here some support is being taken, it is called fulcrum. When you apply force here in downward direction, you must have done in class 6 in science. So when a force is applied here on this, then it is lifted very easily. Without this, it is very difficult to push this large force. But simply using this straight rod, we can lift it very easily by applying force downward by applying force, small force downward, right? So it was a simple machine, simplest machine, or rather I should say. The mechanics, it has branches, some branches. First, it is statics, then dynamics, and dynamics is again divided into two parts: kinetic and kinematics. Kinetic and kinematics. Now next, mechanics. We are going to study about its branches. The first branch is statics. What is statics? It is a branch of mechanics that is concerned with the analysis of load, force and torque, or movement. Force, torque, movement we shall be studying here after motion in second chapter, and then about torque you will be studying in class 11. Acting on a physical system that do not experience an acceleration when force is being applied, but there is no acceleration, but there is no change in velocity, no change in velocity is there, but rather are in static equilibrium with their environment. Means when we are applying force, but there is no change in the body, there is no change in the place, there is no change in the velocity of the body. So this means it remains in the state of rest, static equilibrium, state of rest. So dynamics, now second is the dynamics, second branch. Dynamics word is from dynamic. Dynamic, you must have heard, the boy is very dynamic. He is always ready to help others. He is always ready to do work for others. So dynamic is, dynamics is from dynamic word meaning power. What is dynamics? Study of motion of bodies due to applied forces. When we apply force, means force is applied on a mass, m is mass, and acceleration, change in velocity is there. It is concerned with the motion of material objects. When object is in motion, it comes in motion by applying force in relation to the physical factors. Physical factor like force is applied, then mass, on mass force is applied, momentum change in velocity, and then energy is there. The dynamic means power. Again, I am just reminding you. Now next is dynamic is divided into two parts. Again, it has two branches. Kinematics. Kinematics, it is a sub branch of dynamics. It is a study of motion of a body without knowing the cause. Why a body is in motion? What is the cause? We are not concerned with the cause. It focuses on the velocities, acceleration, position of object. Here we doesn't discuss mass of the body. We have nothing to do with mass. Mass can be small or large. Kinematics doesn't consider the masses of the object. Here, kinema means motion. Kinemic, motion. Now next branch is kinetics. Kinetics is another branch of dynamics that is concerned with the relationship between motion and its causes. Now here we are concerned with the cause. If motion is there in the object, what is the cause of that motion? What is the cause of that motion? If you take a small object, if you take a small screw and just tie it with the thread, and if you try to rotate it with taking its other end to the finger, then it revolves around your, rotate around your finger. So here force is involved, and it is your finger which is applying the force because of this thread. So here its causes, especially forces and torque. It focuses on the causes of different motion objects, such as in case of rotational motion. Here we are concerned with the motion and its cause. Now first chapter in physics in class 9 is motion. So dear students, motion forms an integral part of our life. All microscopic, very minute objects which cannot be seen even by naked eyes, and macroscopic objects in the universe show some kind of movement. Planets, and then stars and other celestial body also show motion. Plants also show motion, but their motion is very, very slight, and this motion is in the form of growth. And there are some objects around us which cannot move on their own. They need some push or pull on them, only they come in motion. So when do we say that an object is in motion? The body is in motion if its position is changed. If its position is changed from a reference point or origin in its surrounding with passage of time, Or we can say that a body is in motion if the distance between the body and a fixed point is changed with passage of time. Here I am taking this example here, this pendulum, you can see, and the bob is at point B, and this is marked as marked with red color. So here we see the distance between this bob and this red point is not changing, but you can see its time is changing. So therefore, what do we say? It is at rest, but it comes in motion. If an external pull is applied on it, then it comes to A position. And here we see the distance of this bob A from this point B, which is marked as with red color, it is changing, and with this time is also changing. Now when it is released, it comes to B only, and then it goes to C. So therefore it moves like this. So therefore we say that it is in motion because its position is changing. The distance of this bob at this position is changing from this point. So therefore it is said to be in motion. Now in previous slide we were talking about the fixed point or reference point. What is a reference point or a fixed point? So here we are going to discuss reference point. Okay. So here in this example you can see this point O is fixed here. This point O is taken as fixed point, and we are talking about the position of this body C, D, A and B. So here this body C is said to be at rest because the distance between this body C and this point O is not changing. Same way the distance between A and O is not changing. So these two are said to be at rest. Now when we can say that this body A will be in motion. So if the distance from body A from O point, fixed point, is changing, and now this distance is increasing, you can see here. Now it is coming to this point, and from here it is going to this direction. So now we can say that A is going in the direction of this marker. So here distance is changing, so it is said to be in motion. So how is the position of an object described? So we can see here the distance of the object from the fixed point is very, very important to describe the position. How far is the body from the horizon? And second is direction. In which direction is the body present here? So you can see its direction is this one, and here B body is in another direction, D is in another direction, and C is in another direction. Okay, now we are going to discuss. Now we are coming to the next topic, that motion. Now sometimes we talk about the distance, we talk about the speed, that my father is driving car at the speed of 60 km/h in north direction. And sometimes we say I am bringing 5 kg vegetable from the market, and my weight is 50 kg weight. So what do you mean by this? So these are the physical quantities, sometimes we say, oh, I am in fever, temperature is 9 degree Fahrenheit. So what do you mean by this? So these are the physical quantities. And what is a physical quantity? A physical quantity is a physical property of a phenomena, body or substance that can be quantified by measurement. Right? Phenomena is natural, means when we talk about the weight, this means Earth is pulling the object towards its center because of its gravity. Gravity means its direction is toward the center. So here the phenomena is there. So, or we can say in simple language, anything that can be measured is called a physical quantity. And a physical quantity, it has three components: numerical component, unit of measurement. As we say 5 kg sugar, so 5 is a numerical component and kg is a unit of measurement. Right? Now third is direction in space. When I say my father is driving car at 60 km/h in north direction, so here you can see direction is involved. The numerical component is 60. km/h is a unit of measurement of speed, and direction is north. So there are some examples: temperature, volume, area, speed, distance, sound, heat, displacement, force, work and energy. So there are some examples of physical quantity. Now after this, what are the types of physical quantities? as I discussed, three components, but out of three, two are in some physical quantities and three are in some physical quantities. Now, physical quantities are of two types. Number one, scalar. Scalar word is from scale. Scale is used to measure the things. So scalar quantity is simple, in simple language, are the physical quantities which require magnitude only, but no direction. As we say, the length of the classroom is 3 meter. So 3 meter, we have nothing to do with direction. So 3 meter is a scalar quantity. 3 is a numerical component, meter is a unit. The scalar quantities can be represented by a number with proper unit, 5 kg, 50 meter, 20. But here 50 kg, if we write in place of kg gram, then 5 will also change. So it will become 5000 gram. So with change in unit, numerical value is also changed. Now what about the property? Scalar quantity with similar units can be added and subtracted by simple arithmetic rules. So like if you are carrying 5 kg sugar and your younger brother is giving you 2 kg vegetables, so then total will be 5 plus 2, 7. But somebody else is giving you 700 gram milk, 700 gram sweets. So then 700 and kg, you can see 700 gram or 5 kg. Units are here different. So we have to convert gram into kg. Then we can add or we can subtract, right? So we have to see units. The units are very, very important. Similar units, when numbers are in with similar units, only then they can be added or subtracted. Now second are vector quantities. Vector quantities are the quantities which require not only magnitude, direction. When I said 60 km per hour in north direction, so direction is there, 60 km per hour is the magnitude, right? So these quantities require magnitude and direction, like displacement, force, velocity, weight, momentum, right? What are the characteristics of vector quantities? A vector quantity can be represented with a proper unit and the direction. The number represents the magnitude of the quantity. We shall be studying in next topic when we talk about the velocity. So velocity is a vector quantity. Direction is there, just I discussed. Vector quantities with similar units but different direction cannot be added or subtracted by simple arithmetic rules. Two or more vector quantities with similar units and same direction. Direction should be same, can be added or subtracted by simple arithmetic rules. We shall be discussing this in next chapter. Right. Thank you till now, and I'm sure you will be revising these topics at home, and you must have understood each and every topic. And thank you very much. God bless you all. In next session, we shall be discussing speed, velocity, average speed, average velocity, and acceleration. Thank you.